Hey guys, can you hear me well? I guess so. Let's give it a start. So I'm Philipp from Project A. Nice to meet you. I'm here to talk to you about how you could analyze the business value of your site speed. But before I start, just briefly about us. Why do we think we can talk about this even? So Project A is a venture capitalist fund based here in Berlin. We invested in around 50 plus portfolio companies by now. We have 260 million euros under management. What differentiates us a bit from other VCs is that next to the VC vehicle, we have around 100 hands-on experts across 9 teams. Personally, I'm from the business intelligence team. That's also why I think I can talk a bit about this. And to give you a quick intro into why we stumbled upon this topic, at some point, there was Christian, who's our director front end. He approached me and said, so basically we spend a lot of time in the front end team making the websites of our ventures faster. I always wondered, what's the business value of this? What's the impact? And then he went on and said, also sometimes we fade out of these companies, and then they start to neglect the site speed and page loading times increase. And I also wonder what's the effect of that, so the negative effect of that on the business. And then he wanted to say more, and I said, okay, let's dig into this. Sounds interesting. So this is going to be very hands-on for you guys. If you're front-end engineers, then you can take this home. We'll also post this on our blog, and you can give it to your analyst. Or you're an analyst, and then ideally you can follow, and we can exchange, and you can probably do the same for your website. So first thing that we needed when trying to answer these two questions of Christian is a data set, right? So on the one side, we need site speed data, ideally on session level, answering the question, how long did the website load for each individual user? And then transactional data. So did the session of this user result in a conversion, let's say a purchase? The right one is fairly easy to get. Usually you have that. The left one is what was new to us, so we needed to find out what is this even, and how do we get it? And then combining that to our data set, where we can calculate the conversion rate per loading time interval. So site speed being quite new to us, in that sense, we first wanted to understand what does it actually consist of. So we stumbled upon something called the critical rendering path. I'm going to bore all the front-end guys between you, but for us that was critical to understand because there's a lot of steps happening between a person hitting the enter button in their browser and landing on your fully loaded site. So this is basically everything that's happening. There's a navigation start, then there's some redirect, some app cache, then there's the DNS lookup, TCP handshake, then there's some requests, a response, and then there's the processing part when the music plays. Because the front-end guys amongst you will know that that's actually where the image loading and everything happens that you can optimize on. So there's a lot of steps in between that we ignore. And we took a deeper look into the DOM loading, DOM interactive, DOM content loaded, and DOM complete. So that's the document object model loading. And the front-end guys told us that this is actually closest to the user seeing something relevant on the site. That's why we focused on this time span. So the DOM content loaded minus navigation start as our page loading speed. And we use that interchangeably with website performance or page loading time. So why that? Because that's the most relevant, as you can say. We know that there's a concept called the first meaningful paint, but that's harder to track because you basically need to visually understand what thing that's being loaded is relevant, and that's really was inaccessible to us, but it's something that we're looking into now. So now we understand what's actually happening when the site is loading. And now we need to get these two timestamps. So basically the DOM content loaded and the navigation start is what interests us. Good thing, there's something called the navigation timing API. You can basically access that with every dev tool in your browser by executing the window performance function. And then you get all these critical rendering path steps that we just had a look at. And you can basically calculate the difference, and you have your loading time of the website you're currently visiting. Well, of course, we don't want to do that manually for every session. So luckily, most of our portfolio companies are using Google Analytics 360. So that comes out of the box. They call it, for some reason, latency tracking KPIs, but it's the same thing. And due to Google Analytics already being embedded in your page, they basically execute this window function, and they get all these tracking critical rendering path steps into Google Analytics. There's one pitfall to it, though. There's something called the site speed sampling rate, and for some reason this is at 1%. So this means that these KPIs are only being stored for 1% of all your sessions. Don't ask me why, but you need to change that. It's not like once you do it, you have it, but you won't recover it historically. So we did that, and then we basically queried everything via BigQuery that we needed, because we had the transactional data already in there, and now we knew what the site speed data actually is, what we needed to look at, and how we could get it. So we have our data set. If you're not using GA 360, then check out our blog. We're going to post how you can do this also manually. You need to set that up custom made, but that's just a little detour. Well, now we have the data set, and we want to visualize it. So this is basically what we did. We grouped all the website sessions into intervals. This is 0.1 seconds intervals. And what you get is a nice little distribution of your page loading time. And it also serves as a cool reminder that you have an average page loading time, but actually it loads differently for every single user. It's very, very worth remembering, I guess. And now there's two ways you can do this, or probably even more. We checked out two. The first one is you do this for the first page view of every session. So really only the first page loading. Or you do this and you take the average over all pages that are being loaded within the session. When you do that, you have the problem of caching. So we try to avoid that and simply focus from now on the first page really being loaded. Then you can basically, for all of these intervals, take all the sessions that you have, take all the conversions that you have, and calculate the conversion rate for every interval. And you get something like this. So here you can see for portfolio company A that the longer the loading time, the worse the conversion rate. So that's what Christian was expecting, right? Saying if I have a faster site, it's probably going to convert better. We said, okay, that might also be coincidence, so let's check another venture. And we saw approximately the same trend here. So that's interesting, right? Now we thought, what about moving all the users that take 4 seconds loading time over to 3 seconds by making the site 1 second faster? What's going to happen would be nice, right? Because there's a conversion rate of 0.5. And if we can move them all up to 0.63, then for every conversion, people are going to convert more likely, and we're going to make more revenue. So let's simulate that. And this is what it looks like. So basically, moving people up in terms of page speed on average by 0.1 seconds would result in a revenue uplift. This is calculated by using AOV, by the way. So based on this, it would be worth making the site faster up until approximately almost a second, and then the marginal utility would decrease. So it's probably not worth so much making the site even faster afterwards. Done, right? We answered the question. Making the site 1 second faster, what's the business value? And we can see, okay, 1 second, approximately 3% revenue uplift. Great. That's of course wrong, because we all know that there's something called correlation and something called causation. So we didn't stop there. and I want to give you a short excursus on why that is. I like this example of sleeping with your shoes on. So basically, you wake up with an epic headache, and also you have your shoes on. And now you could say, sleeping with my shoes on causes my headache. But that's, of course, wrong. We all know that you just went to bed and you were super drunk. So in our case, what would this look like? It could be that we're thinking site speed is influencing conversion rate because they correlate. But what actually happens is that another factor is influencing that. Think device, location where people access the site from, or just imagine that someone is more wealthy, has a faster internet speed because he pays more for it, and also is more likely to convert because he just has more money and is okay spending it. So what we actually need in order to make this assumption that a 1 second uplift in terms of timing will make our revenue increase by 3% is causation. So basically proving that site speed has an impact on conversion rate. And you can do this by excluding other variables, or you can do this by doing a linear regression and using all the potential variables that you can come up with. But that's hard because you need to know all of these, and also it's super complicated. It's also easy to attack. If somebody else comes up with another variable, you basically need to start all over. So what we were thinking, okay, let's do an A/B test. Let's basically isolate site speed and conversion rate. The only thing that we change is really the site speed. We do an A/B test for a longer time, and we see what happens. So you as a front-end engineer, you work your magic and you make the site faster somehow. In our case, that was hard because the site was already too fast, and the front-end team said, no way we can improve this by another second. So we said, okay, then let's slow it down. That was obviously a bit controversial, but hey. So essentially what we want to do is create different groups, have group A untouched, and group B, C, D, increasing the loading time by 0.5 seconds, by 1 second, and by 2 seconds. So this would result in something like this. Basically shifting the whole distribution to the right. How do we measure that? We basically tag all the slowed down variants, all the users that experience a slowed down page via the data layer, so that it is going to be picked up by Google Analytics via a custom dimension. So we have that information back in Google Analytics. And we're currently still running this, and what we expect it to look like is something like this. So basically, the blue line is again the conversion rate that we know from before. So people are converting differently probably depending on their page loading times. The green line is the variant B with a delay of 1 second. And it would look like this if there was causation. And it would look like the red one if there wasn't. Basically, the idea is to exclude all the other variables, like people accessing the page from outside of Germany, and only changing this one variable being the site speed. And if the trend, and it's hard to see here, I'm sorry, if the trend still looks the same, then the result must be that there is causation between site speed and conversion rate. So if it looks a bit like the green line, the trend is comparable to the trend that we had before. We have causation, and if we don't, then there's probably some other variable. Remember, drinking too much, going home, sleeping with your shoes on, that will influence the conversion rate. So in our case, if causation is once proven, then to answer Christian's question, 1 second will result in approximately 3% revenue uplift. and 0.5 seconds in 1.7% revenue uplift. But we're still running this. So what's next for us? We really want to understand if the second part of this, which is the harder one, because you need to run this A/B test, you need to convince the founder of slowing down the page with 3 variants. So that's not easy, but we did that, and now running that and seeing if we can actually prove this causation. And then we can see the front-end engineers then will have an argument in saying, guys, we need to keep up this high speed that our website has, because otherwise the revenue downside will be X. And that X, we have that then. Second is, this is like the first attempt of doing this, so we can easily improve this on all ends. We think the most interesting part is, so for now we took DOM content loaded, right? It's just a proxy. Is the thing that the front-end engineers gave us and said, that's approximately where you see relevant content on the website. But we also read a bit about it, and we know now that there's something else being called the user-perceived waiting time, which basically means that when the first thing that you can actually see and you can use, and it's helpful for you as a user, then the waiting time is over, and not necessarily when the DOM content is loaded. So that's something we want to explore, but that's a bit harder to get your hands on in terms of data sets. And then we want other people to try this. So we're posting this as a walkthrough on our blog. And if you guys go home and you hand this to your analyst and say, hey, please try this, hopefully he does, and we can exchange on the findings and probably also ideas to do this in an even better way. So that's it already. If you want to work on stuff like this, maybe do it together with us. We're always hiring. We have 50 portfolio companies. They're all interested in this kind of stuff. So if you're a BI analyst, a data engineer, a front-end developer, then just apply. If you want to join, shoot me a mail or talk to me. If you have someone else who you know who might be interested in working with us, you can even earn some money by referring them to us via our homepage. Thank you very much. I expect a lot of questions. Yeah. Yeah. Mm-hmm. Correct. As long as you set that up in your tracking, sure. You just need to get that time from somewhere, right? So we use this navigation timing API, but as long as you set this up as events in Google Analytics, then you're good. Everything you need is just whatever you define as site speed. And we tried this with more than DOM content loaded, of course. We tried this with DOM complete and stuff. And the results look very similar. So for a start, we took this. But if you have a way of defining it differently, then you just need to fire the events accordingly. And then you also have it all in BigQuery. More questions? Yes, please. Yes, so this was all real data that you saw, except for this one graph, except for this one. The rest is all real data. This one is something that when you work with young portfolio companies, you need a lot of traffic to run an ABCD test. So unfortunately, it didn't stop, or it didn't become significant until today. So yes, but the rest is all real data. I mean, that's also getting up to this point. Sorry. So this you can do very quickly. Yeah. Mm-hmm. Very interesting. We should exchange afterwards then. I think if you're a front-end engineer, then you basically need this as argumentation points to convince someone that that your site speed is important, right? So getting until this point is probably also helpful already. Then you cannot prove that there is causation. You can see, hey, there's some relationship between page loading times and conversion rate. And then I think most founders will already say, okay, I think it's worth investing into that, but they still might want to know up to what point, and then you need to go that route and do proper testing. Yeah. More questions? Yeah. Mm-hmm. 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 Yeah, and it completely makes sense. Everybody would argue that a faster page is better, right? But by what? And you need to have some business value of this. And you are then also proving, okay, there's a conversion rate uplift, so there's also X amount of revenue being made more now. And that's exactly what we headed out to do. It's especially interesting when you think about the opposite, so not making something faster. In our case, it's more like ventures having quite a fast website, and then they think, okay, now we can move on to other things, and then it goes down again, and page loading times increase, and nobody's aware of the impact this has on the revenue. So that's the main reason why we want to do this. Okay, Martin. Yes, we did, by also using a simulation like this. So basically, you can do this the other way around, right? And say, okay, if we're making it slower, what's the downside? This is the best proxy you can find, but I'm not going to say how much it was. Okay, then thank you very much.